Hey, welcome back. Today we're going to be talking about how to take the derivative of or differentiate position or velocity equations for AP Physics C mechanics students. So I've gone over the basics of calculus that you'll need to know for AP Physics C mechanics, but I just wanted to do some more example problems, and I've taken these and modified them just directly from College Board, full disclosure. But actually that's a good thing too, is that I'm looking at exactly the type of problems that you would see on your AP Physics test itself. So let's go ahead and get to it. This problem here says the speed v of a car moving on a straight road is given in meters per second as a function of time t in seconds by the following equation. And then the equation is written out. What is the acceleration of the car at time equals 2 seconds? So what we're going to want to do here, we're going to say dv with respect to time. If you somehow freak out and forget the basics, this is going to be your basic derivative definition. This is part of your equation sheet. What I'm showing there where it says calculus, that's on the back side of your equation sheet. They actually put this in here to help remind you of this. So we say dv dt of 6 plus 2t cubed. Alright, and we think about what that's going to entail. We take the derivative of 6, that's going to be 0, so that just goes away. And it's really important that we say this is our now acceleration function. We have to write that to be able to get full credit for doing this on an FRQ. This problem right here is designed to be like a multiple choice problem that you could do relatively quickly, but I'm showing you the full write-up. Essentially, 6 goes away, 3, notice that power, the t to the third there, that's going to be reduced by 1, so we need to have t to the seconds. The 3 multiplies with the 2 coefficient out in front there, so we have 6t squared. Now what we can do is we can say, well, the acceleration at time equals 2 seconds. Now what we do is we take that t and we plug in a 2 value. So 2 squared right here, that's going to be 4. 4 times 6 is 24. The units for that are going to be meters per second squared. So the acceleration at time equals 2 seconds is going to be equal to 24 meters per second squared. That's how you go about doing a problem like this. Let's try another one and see how it goes. Alright, and at this point we're going to do more of the same. Maybe you can pause right here if you're up for it and try to do this yourself, see if you come up with the same answer. Go for it. Alright, so what are we doing here? We're going to say dv dt, and we can do that of the original equation, 2t to the fourth minus 2t plus 4, okay? And what we can do is say acceleration with respect to time is going to be equal to, now we look at the 4 exponent, that drops to a 3, so we have t to the third. The 4 comes down and multiplies by the coefficient of 2. 4 times 2 is 8, so our new coefficient is 8t cubed. Minus 2, so that is effectively t to the 1 power. That drops to a 0, you could say, down below. Anything to the 0 power is just 1. So we end up with this. Now we could say, well, our acceleration function at time equals 3 seconds. Let's go ahead and plug this in. So we have 8, 3 to the third power minus 2. Well, 3 to the third power is going to be 27 times 8 is 216. And minus 2 will give us 214. And our units for this are going to be meters per second squared. So we can say our acceleration at time equals 3 seconds is equal to that. Easy peasy, you've got this. Let's try one more that's harder. Okay, and so this one is definitely harder. We're going to write our original equation embedded in the derivative symbol. So dv dt v naught times e, Euler's number, to the negative beta t power, and that's our original equation. So what do we do with this? Well, when in doubt, take a look at this. This is your rule for Euler's number, so for e. Okay, so if you forget, just take a look at this. Again, reminder, it's on the back side of your equation sheet. No shame, just take a look at that and remind yourself of that. Oh yeah, this is how I do it. So notice that this a, this little a, is the coefficient in front of x. It's in respect to x. So that means we can take that coefficient down here. Minus beta is what we have out in front. And then what do we have left over? Well, we've got v naught times e to the minus beta t. Euler's number is a bit of a special case scenario, so it's something to be aware of, but notice we can write our acceleration function is like this. If we take a look at what we have here currently, we have none of those options over here. In other words, I could understand someone semi-panicking at this point and saying, I don't see the option down below. So do you have an idea of what we would do at this point to be able to select the correct answer? Any guesses? Okay, well, this is a really important skill that's going to carry throughout the year of AP Physics C Mechanics. I want you to notice something. They have defined something for us. What have they defined? Well, that V naught times e to the negative bt power, this right here, this whole thing, that is equal to V. We've already said that's equal to V. Okay, well, let's change this around then. Let's say this acceleration function is minus beta times V. Does that do anything for us? And the answer is yes. We've got that as our correct answer over here. And that's how you would solve one of these style problems. So this was just a quick recap and quick overview of how to do some of theyese problems. I've done screencasts on an entire year of physics as well as many concepts for AP Physics C Mechanics. If you have any questions or comments down below, please let me know, and I hope you all have a great day. Take care.